So what is this purpose of the session? Is to give one demonstration what you can do with the combination of interactivity of JMP and utilizing Python within JMP, or let's say the Python integration in JMP 18. And I will use one example we have implemented. It is a bit more complicated application, but it is a good demonstration what you could use. I will demonstrate some techniques that were used in our applications and mention some pain points with the current version. It will be different in 19, I hope, and I have heard that there are changes, but we will see when it's released. And hopefully this will work as some sort of a discussion starter also. This has been in some level presented in JMP Discovery Summit Europe this year. It was a poster presentation. You can find the poster and the presentation from this link here. And this has been, we have had a bit similar idea earlier before JMP 18, when we skipped the integration that JMP had by running Python server that we used. And during my poster presentations, there were few questions, most likely a bit more, but I don't remember all of them anymore. And they were, did we get any assistance from JMP when we were developing this? No, because we didn't really need it. I'm quite good scripter, and we have good Python developer who is also able to write JSL. How did I implement an interactive mode that our tool has? I will demonstrate it here, but it does utilize JMP classes, set function, and XPath. And how do I bring images from Python to JMP? I convert them to base64 strings, and then I can convert them to image in JMP. I should also have a demonstration of this, a script example. So what is the purpose of our add-in? It's called JMPyFacade. What it does is basically bring some features, predefined Python functionalities to JMP users. Most of the time, these are capabilities that JMP doesn't yet have, or then maybe some calculations that Python just is faster to use for. Some examples that JMP doesn't currently have is HDB, scan optics, and light GBM. You can find them from Google or any search engine. We want to have quite similar user interface that JMP platforms have, so it's easier for our users to use. Users won't really notice that it's Python running in the background. There is a startup time that takes some time to load the interface, but after that, they don't really see that they don't really know that it's Python running, except from error messages if there are any. It does have interactive capabilities, and I will demonstrate them. It has we didn't write any documentation for the Python packages. We just collected links, and we provide access to those to users. And for developers, it was supposed to, and at some level it is easy to add new capabilities. It is using base models, or we are building base models in Python. So we define a schema and some capabilities that the services we have. And then JMP is able to pick that schema implementation and create the user interface dynamically. Features we have. So run Python code from JMP user interface, building dynamically the user interface based on whatever Python code has. Documentation can be accessed from the user interface. It has the interactive UI that you can basically run the Python code and it will immediately reflect to your graph, for example. Then we add some extra information to our calculation results, such as input parameters, what were the outputs. And in some cases, we can also build a report, like in here in the top right, you can see Shapley plot from Python. This is what the user interface looks like, and some explanation of them, but I will go through all of these with the demonstration phase, but this is basically so whatever we have users to use, the algorithms and services, homes like in user JMP platforms, inputs you use, and then some buttons. and then some separate pop-up window for interactive mode. Okay, now it's demo stuff. So at the moment I'm using just one table. It's much easier for me to demonstrate it. So what we have capabilities here is when I click any of these, it will update this whole service settings block will be updated based on whatever we have defined that user can add the settings they can use. For example, if it's look at HDB scan, the columns have to be numeric. There has to be at least one, okay, most likely it is two, and then there is no limit how many you can add. Some checkbox, so do you want to allow clusters which only have one value and so on. And then for THNI, for example, totally different options. If user has no idea what these are, we did in one earlier version, we had like a whole tooltips here, but there are so many possible tooltips or explanations that we would have to do. So we basically just took the documentation that the Python libraries have, and then they are explained here. So we didn't start copy pasting basically these. So most of these are exactly the same as user can see here. And then other documentation is guide. So what this can be used for. So we have two types of documentation here if users are not that familiar with this. And this is one example. JMP does have this option. You can, at least in JMP Pro, you can use THNI. But it's a good demonstration of the interactivity. That's one reason why we have it here. Then demonstrating what happens when we run this. Let me bring the table to top. So you can see some changes. Changes will happen here on the table scripts, and then new columns will be created. And let's start running, for example, HDB scan, so clustering algorithm. I don't change any of these settings. It doesn't really matter for this demonstration purposes. So now it was run. It did run the Python code on the background. It created new column and then new table script group here. I will show what the properties are a bit later in other demonstration. Then just demonstrating a bit more complicated options. So now it's a THNI, a bit different algorithm. And then I'll combine that. This is quite common use case that we might do from time to time. So we run THNI and then we cluster those values. And from here, I will demonstrate these examples. So this doesn't really bring any report from the Python side. Basically, it just tells the inputs here, which were used, and the documentation. The Python code which was run is here. So we do have our own functions and so on. So if I run this, it would create on some level a new column for me. It's a bit different because we also do some extra things on JMP side with this application. And then if I have, let's say, multiple different, I'm happy with my results here. We have also a script that I can select these. Sometimes it can be quite helpful. Okay, now we can also give an idea why this could be useful, for example, a Python developer. Not that interactive yet, but JMP has good plotting capabilities. So we can create a THNI. So now doesn't really tell much yet, but when we start clustering it, better if it's like this smaller. And I will hide these -1s because these mean that they didn't have any cluster. So now we have basically automatically created clustering or grouping for these. And now you can, if you wish to make it more visual, you can use JMP's graph builder tools for different type of visualizing stuff. And I think the next one was then the interactive mode. Yeah. These are fine. And this, now I will, sorry, I have to set up my graph builder. I shouldn't have closed it. Let's see what is the best. Okay, I have to run it first once. I will use Teachny for this, so I have to enable it from here, interactive mode. Sorry, this is HDB scan, Teachny. And now it will create the new columns. They are colored, so it's easier to notice what are the interactive columns. And the idea here is that when I make changes to the user interface, let's see if I can make this fit. Yeah. If I make changes here, let's say change this to 10 and I commit it. So when I click somewhere else, it should rerun it. Oh, sorry, it's locked. So now I have to change to 11. But it is possible it's either it's not running or there's no changes happening here. Also no. Some issues with my headphones. We will see with other, hopefully with the other demonstration that hopefully it works, because it didn't do what it should do. It should basically, with any change here, it should recalculate this Teachny. So we will try it with the other application or in other way. And this is a bit more, I make some cleanups to the table so it's easier for me to manage. Because now I will create two different tables at the same time. So this is now Teachny. Basically interactive Teachny window, or should be interactive Teachny window, we will see soon. And then I will create a second one, which is HDB scan. I have to run it once, so I get the columns. So what it does, it basically just updates the values inside these columns. Let's see if it works. Can be a bit tricky to get all of this fit here. In some cases you can just use arrow keys. Yeah, okay, so I'm just pressing up and down on my arrow keys. And it is immediately triggering the calculation. So this is the interactivity capability you can have with JMP and Python, for example. Looking for good parameters. If you have a slow algorithm, it's not that easy. If it's fast, it works quite nicely. And I can also change my values from here. You can see it's much lower here. It will update here. Let's say I haven't looked what could be good values here. Just change some values. And then I can go back to my HDB scan and change the values here. And it will keep updating. So basically I can look for good options for myself. And then you can get the values out of this, but it's easiest if you pick the values around the user interface. Again, it creates the columns in a bit different way without the coloring. So you will end up, what I did disable this interactive mode because for a reason. So now this doesn't have any of the extra things because it would slow down the interactivity. And it doesn't create these because you will end up with massive amount of table scripts. So I did disable the interactivity, I run it once, and now I have my values stored. Those were the demos for that application. And it does have, oh, sorry, I have one more. I won't run it here because it is quite slow. But we have this feature importance, in quotes, feature importance service that will run different algorithms. In this case, like GBM, XGBoost, and AdaBoost, display you Shapley plots on those for the algorithms it can, and then basically calculate or display their importance calculation. And in this case, for example, you could take this, make this into a data table. Again, maybe demonstrating a little bit the interactivity you can have in JMP. You could take average from here, sort this, and now I could take my values from here, copy these, go back to my original table, and let's say pick some of the JMP platforms. Or okay, let's take maybe a bit easier way. So I could now have maybe column switcher in that specific order, or look at the distributions in. You can copy paste this because they are the same name. And then let's take response as the first one. Of course, there are better visualizations for this, but now this should be the most important based on that service, how this affects this X1 response. And you could use then whatever JMP neural networks or partition analysis or bootstrap forest, depending of course what you're doing. But that's just helping in one way to help you find the important features. Then why you should or could utilize Python in JMP. JMP is interactive visual tool, and it has pretty good scripting capabilities. And on the other hand, Python is the most popular programming language for data-related tasks, and it has a lot of different types of libraries and algorithms. It has Python capabilities that JMP doesn't have, and you can quite easily use the Python integration in JMP to utilize the Python capabilities. I think there are two types of basic users for something for the Python integration, maybe, or even for just for JMP and Python. You have JMP first users who are very familiar with JMP, but they are not programmers, but they like the interactivity tools you have in JMP and different JMP platforms. And then you have Python first users who prefer using Python for basically everything what they do. And they don't really use JMP that much, but they could, even they can benefit from JMP, or both can benefit. JMP first users can benefit from Python, and Python first users can benefit from JMP because of the interactivity, interactive capabilities you can have. For example, our Python developer does use JMP for some quick analysis. He doesn't do, I do a lot of scripting in JMP. I don't use Python at the moment that much, but our Python developer, he queries the data either with JMP or with some other tool, and then does some quick plots in JMP, and then goes back to Python. And then, of course, you could have new type of user who is seamlessly combining these two. And then we already have quite good examples of this type of tools in the JMP marketplace. Torch adding, for example. Take these a bit with a grain of salt, because some of these, I'm not sure if all, but some of these will change in JMP 19, to my knowledge. And just a note, stuff to note from the integration. Initial loading per JMP session can be slow because Python and all the packages you are calling will be loaded into memory, so it can take some time. You can have some issues with package management and installation. There was, I think yesterday, a post in community or some few days ago that they couldn't use pip, but the reason was basically that they have strict firewall rules, so you cannot install the packages. That's one issue you can have, for example, with the package management. And then if you have, depending, if you use, for example, Anaconda, Python, JMP's Python cannot access it that easily. If you are a Python developer, you most likely are using some sort of virtual environments. In JMP, you only have one environment. And this one environment and how the scoping works, it can be, at the moment, confusing. Where in which namespace or scope are your JMP and Python variables? How can you access them from Python to JMP and from JMP to Python. It can be quite confusing from time to time. And how you can then reset the Python. You want to test your script. At the moment, basically the only way is to close your whole JMP session and rerun it to reset the Python. And then one more, this is something we did face with, for example, with this JMPyFacade, is the type conversions. Some Python libraries in JMP doesn't really matter that much, but some Python libraries are very strict if you have float or integer, for example, and how JMP converts, for example, if I have a big class table. Big class table is a good example. And I take these values to Python. What would they be? That's something you can try. Most likely they will be integers. And if you have a calculation that requires floating numbers, it will fail. Or in some cases, if you provide it integers, it will use different calculation. Like in JMP, for example, if I change this to, let's change this to nominal, for example, it will be totally different if I use distribution on these. These are now continuous values and these are nominal values. Stuff like this can happen depending on how the conversion goes. So it's a good idea, test them out and then read this JS to Python interface from JMP help page. And then of course, there are some types which cannot be directly converted. I think JMP basically can convert the data table, but it is using a work around it. It's using, I think it converts it to CSV first and then opens it in a Python. And then other one is the images. But there are workarounds for both of these. And at least images, to my knowledge, is changing in 19. Most likely, I would guess that data table is also. So then some implementation stuff we have in our application. Not the correct use maybe for Pydantic. You can basically define models or base models for it. It's very useful if you are building APIs, for example. You can do data validation and stuff like that. But we are using it to define these type of fields. So here what I have highlighted is that this is a cluster selection method, is the argument name. It is a string. And then it has, in this case, this EOM is a default value and it has a pattern. And we in JMP, then we will parse this pattern here and create a combo box out of it. All of these different types of display boxes are separate classes and they are parsed from something like this. So this is a list of strings. It is here. It's column list box with a button. Minimum cluster size. It's here, and it's you can see it's an integer with default value of 5, and it has to be greater or equal to 1. So we can limit the values here. I think we do currently the data validation as much as we can already with these. So I have this min cluster size has already set the minimum allowed value. You can do that with number edit box in JMP. So we don't use it that much, the Pydantic side. We could call with these arguments the Pydantic and ask it to validate the values. But we can also do a big part of that in quite easily in JMP. And then we have class. We are using JMP classes to create this. It's easiest to manage, in my opinion, with this type. This is complicated enough already that you should or could utilize classes for something like this. It's easier to build these type of user interfaces, in my opinion, with classes. And then just some examples how they map together. So list of strings is column list box, and we have a class called JMPyArray field interface, and so on. And then this is one way how you can get image from Python to JMP. So simple example here, this is Python code. So we create an image here, and then we convert it to base 64 string or decode it. And then in JMP, you can use this type of JSL to convert it into an image. And it's at the moment, it's quite easy to do it this way. Other option, quite good option, is to save it, for example, to the temp folder, and then go and open the file from the temp folder and show it in JMP. There is this type of a bigger example script in earlier Scripters Club session. So this is from there. So here it's just using Python submit to create an image. Same idea. But here basically we don't use this. We don't have function. We just go and pick this data from the Python side of JMP here with Python get. But again, it's not using like a saving the file anywhere. It is in the memory. Then how the interactive method has been implemented here. It's not the most simple one, but it is, the basic idea is that we are using set function. So this is now one of the fields, for example, checkbox. The reference could be a checkbox or number edit box. We are using set function, and then here is the key point. It is using method, not function here. What this means is that this, whatever is inside here, is able to access the class. If it's a function, it doesn't have knowledge of that. With method, it does. I think it is mentioned somewhere in JMP class documentation. And then because this doesn't have all, okay, it does have quite a lot. You can get quite a lot of different things if you just have a reference to yourself, like in here. It goes and picks the reference to the window, the window you have open, and then it uses XPath to find basically the locking checkbox value. And if it's on, it has a different feature than if it's off. And then the final thing is here. So if it's not locked, if it's not locked, what this does, if I can find my user interface here. What it does go here, it finds a reference to this button and clicks it. The reason I'm doing it in this way, it's as this button click has a script behind it, and it does a lot of different things. If I just use the JSL and click it, it will perform all of those actions. Other option would be to call the function that this is basically using. This is just much simpler way of doing it. You can click, you can use JSL to click buttons in JMP, basically. And it works here really nicely. And one thing to note is that I'm using set function. It works for most of the display boxes in JMP, or that you can give inputs. I'm not using any set text changed or set number changed or whatever features the display boxes can have. One reason is that when they trigger is different. If you are using a set function, it will trigger when the change is committed. So if, for example, with text edit box, it is when you press enter or click somewhere outside of the text edit box. If you are using set text changed, it will trigger immediately when you write anything. And it can be quite annoying to work with it, depending what you are doing, of course. But for example, if I had a text edit box in this here, and I tried to write something that I want to do, for example, or give a value for a good result or something like that. Immediately when I start writing, it would trigger every key press. Even I wouldn't get to write or finish my writing, basically. That's why we are using this set function. And most of the time I do use set function. There are some cases for those other options, but this prevents that JMP triggering too many times. Then the interactive pop-out window. So these which were popped out, such as this. It does create its own window. It has its own class, which is basically the same class that is inside the big window, but it's just a small block of it. These are locked on purpose, so user cannot change these anymore. You are just playing around with these settings here. And there are some examples of how these have been implemented. These are so this gives maybe a bit more idea of what we overall are doing. So this is the model schema. So this is the schema that has been defined on Pydantic side. Then this is the name in the user interface that you can see. And then the rest are basically separate for this pop-up window. This super init is using now the like a higher level class. But it tries to use as many of the same capabilities as we have already written. So I don't have to write everything twice. Or okay, it's fine to write it twice, but then if I have to make any changes, that's when it gets annoying. I think this, let's see if this, yeah, this is last implementation thing. What we at the moment do, we don't update the values on the Python side. And we decided to do it this way because we assume it will save us a headache, and it did at some point. It's easier that what we do is we take the values the columns user has selected, and then we take non-excluded rows and we create a subset, private subset, and we just send that private subset to Python side, or basically we call a Python function with that table. And then the Python will run its magic. Basically, I think it will take that subset, create a data frame from that, and then run its calculations on the data frame, update the private subset, and we will then use finally JMP's update function to update the original table. This gives us, it's easier for us to manage which are new columns from the JMP side, and we can update them and do auto cleanup on the JMP side when we are doing it like this. And then also we can, now when we get the return result, the Python doesn't return the table because we already know what the table is, the subset table. It will return this JMPy results. And this is basically, I think this is a dictionary. So in JMP, it will translate into associative array. And when we get this from the Python, we know that the Python has finished the calculations. I think I'm not sure if we did in this application. Let's see if I can, okay, not here, but we might add indexing to the table so it's easier to update. So before we send the data, we create an index to a table and then update based on that. And one reason, we had tried to have some sort of separation between the Python and JMP. We don't like, okay, yeah, one reason is we try to avoid using run JSL on Python also. So maybe in 19, we could update the table directly if it gets a bit easier to do everything, creating new columns and stuff like that. Then that's for my example here. Then just some other examples. I won't go through, but you will get these slides, so you can click these. So you have examples in JMP Marketplace regarding the Python integration, Python data connector. I think these might be coming in JMP 19. I'm not sure if you're able to do this yet. I haven't tried them, but this data connector, for example, is a great feature that can have quite a few different uses. Then you have these different algorithms or calculations, machine learning, torch depadding, for example, if you have JMP Pro. And if you want to see how these have been implemented, you can download these from JMP Marketplace. The add-in, you can install it, or you don't even have to install it. You can just open it as a basic zip file and then look into the code. So you can see how, I think all of these are made by JMP staff, so you can see how they have been using this integration. Then some links from community. So this is one way of taking normality for many parameters. And this is, if I remember correct, this is way faster than what you can do in JMP, because you don't need to have the run, for example, distribution first and visualize anything. It will just perform the calculation. Good example here. Then JMP cannot work with some specific type of numbers. You could go to Python, do the calculation in Python, and then return the value to JMP. Maybe not as a number if JMP cannot handle it, but maybe as a string, or separate it into few different numbers. And then more links regarding the integration. Scripting guide, it is good to read through. And then just check from JMP community, search different types of comments and posts by Paul Nelson. I think he's the main developer behind this integration. He has he has provided quite a lot of like background information regarding how this works and what you can do and what you cannot do and why. What is the reasoning behind it? Then some presentations. So this was from the Discovery Summit, and this is Paul's presentation. And this might be also Paul's presentation. And then this is Paul's post how you can have a basically function within a JMP that uses Python, but you don't see the Python at all. These are good to go through. Then earlier version of this, how running Python code with JSL, it has different examples like some simple creating a column, getting data from Python to JMP, extracting the image. It was demonstrated here. Yeah, I think that's it for my presentations. Any questions regarding the Python integration or okay, Olga has a question. At the moment, we are not, because there hasn't been basically enough interest for it. So we won't basically share if we don't get anything out of it. It has been quite common that some people might ask from us, but they don't provide anything in return. This could have potential for some sort of open sourcing, how it could be done. Maybe not the way we have done it, but developing a new way of doing it. This might definitely not be the best way how it could be done. I haven't looked into these, let's say not these two first, but these three, how these have been created. They could have, for example, quite good ideas for our application also. But there could be a benefit of developing something together like this type going. Basically what we are doing, we are going for Python data type to JMP display box, basically. There is a lot of coding. In this version, George asked how much coding effort is behind the application. In this case, most of the coding, let's say the idea happened here, the earlier version. We had a good idea already there. And now it has a lot of code. I cannot show my code, but I can take a peek, for example, how long. It has multiple different files, but most of them are quite, depending of course how the type of scripter you are, they're quite simple. Let's see, this could be maybe a good example. Yeah, this is good example. This one I can demonstrate. Oh, let's make it a bit bigger. If my JMP doesn't freeze. So this is one of the interfacing classes we have, and it doesn't have that much code. But of course, from here you can see that it has a base class. So this base class does have some code, which is not visible here. See if I can find it. It should be, okay, it's named a bit weirdly. Let's see if I can maybe show that. Or at least tell how much code it has. Okay, a few hundred lines. Yeah, this doesn't have anything that couldn't be shown either. So this is what is behind there. So these are then from utilizing, these are done to utilize Python's classes. You can have these to printing features. Mostly useful during the development. They are not that useful during the use. Maybe for debugging. For debugging purposes, you can use these. And then these just define some functionalities that all of these have. But it has a lot of lot of quite simple code, some complicated stuff. And then on Python side, I know that it would require a rewrite. It's quite complicated. We want it to be easy. I did mention it somewhere here, but it's on purpose on quotes. It's not that easy as we hoped for to add new capabilities. Let's see, where was, yeah, here. For example, this is just the setup for the base model. Outside of this, we have then the functionalities, how you can call these or use these. And then, because they are not, for example, all of the algorithms are not from scikit-learn or some simple NumPy matrix calculations. They work in different ways. You expect that you get some sort of input, but it's different this time because you had a bit different input value. So it takes a lot of work to get them work. Like having this many different capabilities working easily. I think not all of these even work. This is updated version we have, but there might be some of these that they don't even work properly at the moment because for example, the type conversion is one. If I were to run this feature import as on nominal, integer column which jump will translate for the Python to integers, it will be very slow because most likely all of these, they will start running more heavy algorithms. They will, okay, this is integer, so I will consider it as a nominal value, or maybe I'm not sure if they consider it as a nominal value, but they will calculate in different way than they would for continuous value. So there are stuff like that, which has maybe created a bit worse looking code that we hope for, and it makes it difficult to update. But I think the slowest part for us was already done in JMP 17. We had the idea, we follow this a bit similar idea here. Of course, now we can use the integration, but we are utilizing the similar idea. We couldn't reuse the code, but it was quite fast to rewrite most of the code for us. I can say one more thing about this is that we don't, when user installs this add-in, when they run it first time, so this is built as an add-in, but when they run it first time, it will go and check from our own package management. We don't use pip to update the packages, so we have checked what we want to allow and which versions to use. So we have some limitations. So we don't allow from this, or we don't want this to go and collect any of the Python packages just using pip. So we have screened in quotes whatever we wish to use, which versions we want to use with this application. And then I think we use some sort a bat file to run the script to update the Python packages. A bit in some similar manner than I think it's an idea that JMP has somewhere in JMP's installation folder of some bat file.